I'm going to do 4 examples with you. Hopefully, that should cover all the GDC skills that you need to have for this topic. Example 1. Each time Pam visits the library, she borrows either 1, 2, 3, 4, or 5 books. And you can see the probability density distribution table here. The first question up is asking us to find the value of A. Now, since we know that all these probabilities must add up to 1, we just need to use 1 to take away the rest to find out the value of A. So we can do A must be equal to 1 take away 0.16, take away 0.15, take away 0.28, take away 0.16. So A is equal to 0.25. The next question, probably the first time you have seen it, is asking you to find the mode of the distribution. Now, the mode is like any other, it's the same term in statistics that is the most popular number. Now, we know that A is 0.25. Now, when you compare all the probabilities, 0.28 is the highest. So the mode is actually 4. Part C. On average, how many books does Pam borrow per visit? Now, on average, so it is asking for the mean. Now, learn to do this using your calculator by bringing up the spreadsheet from the home menu. So this is the spreadsheet. Make sure you give the columns that you use a heading. So first one is about the number of books. So simply put in books. The second column is probabilities. This is pretty much like your frequencies. So number of books is 1, 2, 3, 4, 5. Probabilities 0.16, and you just enter them accordingly. So now you have 2 columns. Like I have mentioned before, this is quite easy, just using the calculator to calculate the mean. You need go to stat calculations, so menu, statistics, stat calculation. It is one variable stats. Although you have 2 columns, it is only about the number of books. So one variable then. You have one list. The first set of information is contained in your first column, books. Then the second column store all the probabilities, which are like the frequencies. Now, tell the calculator to make the output to go to the first empty column. And if you click, this is the mean, 3.13. You can tell from here, you can, of course, scroll to the right. You can tell from here that it is 3.13. Oh. In other words, Pam, in average, borrow 3.13 books. It is okay to leave it in as decimal. There's no need to turn it into a whole number. Now, what else can we do here? Now, of course, it is not asked in the question, But I'm going to use this opportunity to tell you that we can actually do a graph. So I'm going to do the graph to show this distribution. We need to go back to Home key, bring up the chart, this one. You see the 5 dots, 1, 2, 3, 4, 5. Click, turn it into books, turn it into probabilities. So imagine you see them as bars. Make sure you don't connect them using a line, but they are individual bars. Sometimes you might get asked to do something like this. So I copy it down to remind you that this is something that you can do on the charts. Well, going back to here, apart from getting the mean, we can also get this sigma x, which is the standard deviation, which will come into handy if you're asked. So I might just insert this. So you can see we can use it to enter the data as 2 columns, use the data to draw a chart, and then use the data to calculate some useful statistics. Let's try example 2. Now I'm going to clear I'm going to new document, and make sure you don't save it. Just bring up a calculator. Suppose X has the probability distribution alongside here. Given that the expected value, the mean, is equal to 2.8, find the value of A and B. So one thing we know for sure already is that these should add up to 1. So write down what we know. We know that 0.2 plus A plus 0.3 plus B is equal to 1. So rearrange it a little bit, we can see that this is actually equal to 0.5. This becomes our first equation. We are ready to use this expected value. How do we calculate the mean? We calculate the mean by doing the value times the probability plus the second value times the probability, etc. So what we need is this. We need to do that times that, and then add them all up, and that should equal to 2.8. We write it down. 1 times 0.2 plus 2 times A plus 3 times 0.3 plus 4B, all equal to 2.8. So we will have 0.2 plus 2A plus 0.9 plus 4B equal to that. Now we can see that 2A plus 4B is equal to 2.8, take away 0.9, take away 0.2. So let's take away 1.1. So it should be equal to 1.7. So that's our equation 2. At this stage, if you are really confident with your algebra skills, of course, you can solve it by hand. But you really should also know how to use the GDC to solve this. Now we have two equations here. So we have one saying that a plus b is equal to 0.5. The other one is 2a plus 4b is equal to 1.7. So we have two of these. Calculator, we need to go to the algebra because we're solving simultaneous equation. Menu, algebra, solve system of linear equations. We have two equations. The variable, we can change it to a and b because that's what we're using. A plus b equal 0.5. Then go down to the second one, 2a plus 4b equals 1.7. Now, this is all ready, and then press A is therefore equal to 0.15 and B is equal to 0.35. So they add up to 0.5, which check. It's good. I'm gonna insert it here, so next time you know what to do. Example 3. Now this I'm going to let you have a look at the question first. See if you can tell what do you have to do. Okay, right. For this question, we actually need to identify ourselves. It is about binomial distribution. Now, how do we tell? We can tell from looking at 40. So the calculators is either working fine or they are 40. So there are only two outcomes. Once you start from there and then you think, oh, do I have a fixed number of trials? And indeed we do. We are only concerned with 100 calculators. Next, do we know the probability of a 40 calculator? It says over a long period of time, 2% of them are found to be 40. Basically, it's saying that every 100 calculators, there are 2 that will be 40. You can expect that. So now we have identified all the parameters. We know that n is equal to 100. Probability of success to get a 40 calculator is 0.02. So this is a binomial distribution with these values. A. Write down the expected number of 40 calculators in the sample. So the expected number is equal to NP. So you just do multiply the two values together, equal to 2. For every 100 calculators, you can expect 2 to be 40. B. Find the probability that 3 calculators are 40. So this, under the discrete random variable, we want exactly 3 calculators. So we are looking at the probability of x is equal to 3. So we need to do binomial PDF, because it's exact value, we have n equals to 100, probability equals to 0.02, and we want it to be 3. Stats, distribution, binomial PDF. That would give us 0.182. C. Find the probability that more than one calculator is faulty. More than one, so we can set up. Can it be equal to 1 when is that more than 1? So it cannot. So you have to say, oh, probability of x has to be greater than 1. Now, what does that mean? What do we have to do? So we must make use of a cumulative one. So let's see, we go back to here, statistics, distribution. This time we need the cumulative one. We have 100 calculators, 0.02 chance of it to be 40. So more than 1, 2, and then the upper bound, 100 for all of them. So the probability of that happening is 0.597. Now I'm going to write my calculator command line down here. So we did 100, 0.02, 2, and 100, 0.597. Last example. Let you have a look. So now we're dealing with bags of rice. The mass W of bags of rice follows the normal distribution, with the mean of 1,000 grams and the standard deviation of 4. At this stage, you can already write down the random variable. Oh, we're not using X. The random variable W follows the normal distribution with the mean of 1,000 and a standard deviation, but we use variance, so you need to write 4 squared. So you can write that down. Find the probability that a bag of rice chosen at random has the mass between 990 grams and 1004. So write down the weight has to be in between 990 and 1004. Now go to your calculator. We do menu, stats, distribution, normal CDF. We have the lower bound, which is 990. The upper bound is this, 1004. Press OK, and you can see this is what you get. Write down what we have entered. This is equal to 0.835. Next, 95% of the bags of rice have a mass less than kilograms. So what does that mean? Now, I mentioned before, it is best to do a sketch. If we do a sketch here, we will have the mean at 1,000. 990 is about here, 1,004 about that. So let's do one ourselves. So make a sketch. So you have 1,990 and then 1,004. So for B, if you do a sketch, it says 95%. 95% must be 0.5 plus 0.45. So you must include areas of the left-hand side and more. Okay. This is the mean, this is the value of K, and we were told that this area or the probability is 0.95. And what is K? In this case, we must use inverse normal to work backwards. Since the area is from the left over here, we don't need to do any tweaking. We just need to enter it directly onto the calculator. So statistics, inverse normal. The area is 0.95, 1,000. Oh. Turns out K must be equal to this 1,006.579. Now, if we stick to the rule saying that we need to round it up to 3 significant figures, then we would do, so 3 significant figures starting from 1 is 1, 2, 3, and you must round the 6 up, so you will get 1,010. In other words, 95% of the bags of rice have a mass less than 1,010 grams. 1,010 grams. Last one. For a bag of rice chosen at random, the probability of it existing between these two weights, so 1,000 take away A and 1,000 plus A, is 0.9. As you can tell, this is symmetrical because it's taking away and adding the same amount plus or minus A. The area is 0.9. If you think about the picture of it, then symmetric about the mean. The area is 90, so it's pretty big. .9, so that's the area. This is 1,000 minus A. This is 1,000 plus A. And we're trying to figure out what A is. So what can we do? Well, we need to use a little bit more of the symmetrical property of the normal distribution. We cannot say, oh, the area from the very end, left end, to here is 0.9, because this part is not included. What we do know, though, is that we can split it up. So this side is 0.45 and this side is 0.45. That's what we know. We also know that each side must have 0.5. In other words, this little bit that is not shaded must be a split between that, 0.05. So the big area is 0.45, the smaller bit is 0.05. That would give us 0.5 in total. Same over here. This bit is 0.45 and this end must be 0.05, giving us 0.5. Knowing that this is 0.05, then we know all the way from here is actually 1 minus that, which is 0.95. So we do now have the area, including this bit. So if I shade it, maybe it's easier to see. So what do? We need the inverse normal. We know the area is 0.95. The mean and standard deviation is still like this. Well, let's work it out. I'm going to copy that down. We actually already have that. Look, it's exactly what we have done before. So we know, without even needing to enter it, we have 1006.579. Now I'm not going to use the rounded value. I'm going to use this value to work out what A is. So this is the same as this. So in order to find out what A is, I must take 1,000 away from that value. So A must be equal to, take away 1,000. So we have 6.579, or roughly 6.58. This is to make good use of the symmetrical property of the normal distribution. Hopefully I have covered most of the GDC skills. If you think that I have missed anything, feel free to email me and then I can help you with that.